there's a point charge at the origin, and you're told that the potential difference between 1 meter and infinity is 9 volts. And the first thing you're asked is, how much work does it take to move 10 coulombs from infinity to 1 meter? The potential difference between 2 points is the amount of work it takes to move 1 coulomb of charge from one point to the other. So 9 volts, it means it takes 9 joules to move 1 coulomb from infinity to 1 meter. So if you're moving 10 coulombs, the amount of work required is 90 joules. Now you are asked for the value of that point charge at the origin. To find the potential difference between 2 points, you integrate minus E dot dl from one point to the other. For a point charge at the origin, we know that the electric field intensity is the value of that point charge over 4 pi epsilon sub 0 times r squared, and it's in the radial direction. Since the integrand is E dot dl, we will only get a contribution to the potential when we're moving in the radial direction. So our differential length to use will be just dr in the r direction. So we substitute for E and substitute for our differential length. So we'll factor out our constants. AR dot AR will just be 1. So our integrand will be dr over r squared. And when we integrate that, we'll get Q over 4 pi epsilon sub 0 r evaluated between 1 meter and infinity. So we'll end up with Q over 4 pi epsilon sub 0 times 1 over 1 meter minus 1 over infinity, which will be Q over 4 pi epsilon sub 0 times 1 meter. So our potential difference is 9 volts, and that's equal to Q over 4 pi epsilon sub 0 times 1 meter. So we want to find Q, so solving for Q, we see that Q is equal to 9 volts times 4 pi epsilon sub 0 times 1 meter. So let's substitute for epsilon sub 0. So we have Q equals 9 volts times 4 pi. Epsilon sub 0 is 10 to the minus 9 over 36 pi farads per meter, and then times 1 meter. So we have a meter cancels. This 4 pi will cancel with this 36 pi, leaving 9, and then this 9 and this 9 will cancel. So we have 10 to the minus 9 volts farads. A farad is a coulomb per volt. So we're left with 10 to the minus 9 coulombs, or 1 nanocoulomb for our point charge.